Good day everyone. In this video, we're going to learn about alpha, beta, and gamma rays in 15 minutes. By the end of this video, you should be able to differentiate the three types of ionizing radiation in radioactive decay. Before we go further, let's do some revision on what you have learned before so that we can recall the terms and concepts that are related to the topics we're going to discuss in this video. I believe this will help you to understand the topic better. So first, let's look into the composition of an atom, which I believe all of you have already know that an atom is composed of subatomic particles called proton, neutron, and electron. Positively charged protons and neutrons with no charge form the central nucleus, while the negatively charged electron orbit the nucleus, as you can see in the picture. Now, can you recall the like charges repel and unlike charges attract each other? Considering this, you should expect that protons being of the same charge and so close together in a nucleus would exert a strong repulsive force on each other. But how can protons and neutrons hold together in the nucleus? In order to overcome the positive electrostatic repulsion between protons, a strong nuclear force is needed to hold the positive protons and neutral neutrons together in the nucleus. The amount of strong nuclear force which holds the positive protons and neutral neutrons in a nucleus determines whether it is stable or unstable. In a stable nucleus, the force is strong enough and brings sufficient energy to hold the nucleus together permanently. Okay, I'm sure you have learned about this radioactive decay in the previous subtopic, but let's just recall your knowledge here. What is radioactive decay? Radioactive decay is a random and spontaneous process where an unstable nucleus emits radioactive radiation until the nucleus becomes more stable. Remember when we talked about the strong nuclear forces in previous slide, which determines either a nucleus is stable or unstable? But what makes a nucleus unstable? An unstable nucleus either have too many protons or too many neutrons, which upsetting the strong nuclear forces. Let's imagine it this way. Let's say you're going for a picnic with your friends, and there are 24 of you. You're going by bus. The maximum capacity of the bus is 20, which means only 20 passengers can be on the bus, but there are 24 of you. When all 24 of you ride on the bus becomes unstable. The seats are not enough for everyone. So now what are you going to do with the excess passengers? Of course, you have to remove the excess passengers in order for the bus to become stable again so that it can travel to the destination. And this situation or this process is similar to the radioactive decay, when an unstable nuclei try to balance themselves by giving off the excess protons or neutrons. Just now we mentioned about radioactive radiation, which I actually would like to refer to ionizing radiation, which you have already learned about this ionizing radiation in previous subtopic as well. So let's just recall what you have learned before. When a radiation passes through air and produces positive and negative ions, then it is known as ionizing radiation. So the keywords here is produce positive and negative ions. The ionizing radiation is electromagnetic rays that have enough energy to ionize atoms or molecules. The radiation has enough energy to break the electron bonds to atoms or molecules, thus forming ions. There are three types of ionizing radiation that are produced during radioactive decay, which are alpha particle, beta particle, and gamma ray, which we will look further into the differences between these three radiations in next part. Before we look into the differences between alpha particle, beta particle, and gamma rays, let's go through the similarities between these three radiations. All of these radiation are radioactive rays and they cannot be seen with the naked eyes. Since they are radioactive rays, they are harmful if not handled with correct procedure. So now let's go through the differences between the alpha particle, beta particle, and gamma ray. We're going to look into the differences between this radiation in terms of their particle size, their charge, their ionizing power, penetrating power, deflection by magnetic field, and deflection by electric field. Let's look into the differences between alpha radiation, beta radiation, and gamma ray in terms of their natural characteristic, their size or mass, and their charge. Based on the diagram, we can see that an alpha particle is made of 2 protons and 2 neutrons, which is identical to a helium nucleus. So the natural characteristic of an alpha particle is helium nucleus. Alpha particles have approximately 4 times the mass of proton and neutron, since alpha particle consists of 2 protons and 2 neutrons bound together into a particle. So their size or their mass is large and their charge is positive, since it is made of protons and neutrons. While beta radiation or beta particle is a high-speed electron. Since it is an electron, their mass or their size is small and their charge is obviously negative. On the other hand, gamma ray is a high-energy electromagnetic wave which they have no mass and their charge is neutral. Next, let's look into the differences between alpha particle, beta particle, and gamma ray in terms of their ionizing power and penetrating power. First, what is ionizing power? Ionizing power is the ability to convert atoms to ion with an adequate amount of energy, while penetrating power is the ability to penetrate materials. Penetrating power of nuclear radiation depends on the ionizing power of the radiation. The radiation continues to penetrate matter until it has lost all of its energy. The further it can penetrate into the substance, the more spread out of the ionization it causes will be. So, the more localized the ionization, the less penetrating power it will possess. Radioactive emission has an ionizing effect. The three types of radiation are highly energetic and use their energy to remove electrons from the air molecules when they pass through air. The ionization of an atom produces positive ions and negative ions, and due to their different charges and masses, they have different ionizing abilities. The penetrating effect of alpha, beta, and gamma radiation depends on their ionizing power, as I mentioned before. Radiation, which has a stronger ionizing power, will have a lower penetrating effect. The radiation emission loses some of its energy each time an ion pair is produced. Now let's look into the diagram. As you can see from the diagram, an alpha particle loses energy very quick as they move through a medium. After a short distance in the medium, the alpha particles would have lost almost all energy. So, alpha particles have the lowest penetrating power. Alpha particles can be stopped by paper, as you can see from the diagram, while beta particles have moderate penetrating power, which it goes through paper but can be stopped by thin metal, for example, aluminium. While on the other hand, gamma rays can go through paper and metal sheets and can only be stopped by thick lead or concrete, since gamma rays have high penetrating power. As we have discussed before, alpha particle has large mass and positive charge, which because of their large mass, it has the highest ionizing power. That same large size of alpha particles, however, makes them less able to penetrate matter, which means alpha particles have the least penetrating power. While beta particles are highly energetic electrons that, being smaller than alpha particles, allow beta particles to travel further but ionize less. So beta particles have moderate ionizing power. Beta particles can penetrate quite deeply into matter before its energy has been used up, so their penetrating power is therefore moderate. Gamma rays are purely energy with no charge and no mass. Thus, their interaction with matter is much less than the other two radiation. Gamma rays have an ionizing power so low that they penetrate very deeply into matter before most of their energy has been used up. So the penetrating power of a gamma ray is very high. Alpha particle, beta particle and gamma rays behave in different ways. So let's see how they interact with an electric field. Based on the diagram, you can see that we'll have a positive electrode here and negative electrode here, and we have electric field between them. We know that alpha particle is a helium nucleus with 2 plus charge. So, if the alpha particle is fired into the electric field, the alpha particle is going to go towards the negative side because opposite charges attract. The beta particle is an electron with a negative charge, so the electron or the beta particle is going to be deflected towards the positive side. Now, have you noticed that the beta particle is being deflected more? Even though the alpha particle has a 2 plus charge and beta particle has only a minus charge, the alpha particle is approximately 8,000 times heavier than the beta particle. So, it takes a lot more force to deflect the alpha particle. Thus, the alpha particle is deflected less than the beta particle, while beta particle is very light, so it deflects more. Gamma radiation or gamma ray are not particle and they have no charge. So, the gamma ray is not affected by the electric field at all. It will just going to keep going straight, like we can see in the diagram. Next, let's see how these three radiations interact with a magnetic field. In order to see how the three radiations deflect in a magnetic field, we can use the Fleming's left-hand rule. So we know from electromagnetism that the first finger is the magnetic field, the middle or the second finger represent current, which goes from positive to negative charge, and the thumb is representing the movement. So from the diagram, we have magnetic field going from north to south in that way. The positive charge is going that way. So by using the Fleming's left-hand rule, the movement is upward. So alpha particle travel upwards. We can do the same with the beta particles. The magnetic field still in the same direction, but the charge is opposite. This is due to the beta particle which has an opposite charge. So, by using the same Fleming's left-hand rule, the movement is now downward, which means beta particles travel downwards and get deflect more than alpha particle due to its lighter mass. The gamma ray once again have no charge, so they are not affected by the magnetic field as well, so they continue to travel in straight. Finally, it's time to test your knowledge. Let's solve this crossword puzzle together. The first question, what type of radiation is stopped by aluminium? The answer is beta. The second one, gamma radiation is this type of wave, which is electromagnetic wave. The third question, a random and spontaneous decay process of an unstable nucleus by emitting radioactive radiation, which is referring to radioactivity. The fourth question, what's gonna stop gamma radiation? The answer is T-clad. The fifth question, this is the most penetrating type of radiation, which is referring to gamma ray. And the sixth question, an alpha particle is this type of nucleus, which is helium. And next question, this is the most ionizing type of radiation. Can you recall? The answer is alpha. Eighth question, what's gonna stop alpha radiation? The answer is paper. And the ninth question, who discovered radium and polonium? The answer is Marie Curie. And last question, a beta particle is a high-speed electron. So I hope you should be able to differentiate the three types of ionizing radiation. And I hope you enjoy this video. Thank you.